Welcome back to part 3 of dividing polynomials. I'm Professor Duresh, and in this video, we're going to talk about polynomial long division, which is the primary technique for dividing complex polynomials. When we're thinking about polynomial long division, we want to connect what we're learning to things that we've learned in the past. So we're actually going to start with an example of long division with integers instead of polynomials. And we're going to talk about the process we use to divide integers. Here, we're going to find 875 divided by 25. Now, there's no remainder here because 25 is going to go evenly into 75, but we can see the setup. Start by putting the 25 on the outside of the division, then using your division bar and putting 8, 7, 5. When we divide, we're going to take what's called the divisor, and we're going to ask ourselves how many times divisor divides evenly into the beginning terms, or in this case digits, of the dividend. So 25 is not going to divide evenly into 8, but it is going to divide into 87. So what we're calculating in this first step is 87 divided by 25. 25 goes evenly into 87 3 times. So step 1 is to divide front term. Let's say the front term so it's a full sentence. Then we need to distribute the 3, which is called the quotient, back to the divisor. 3 times 25 is 75. Step 2 is to distribute. Finally, we need to find the remainder. So we're going to subtract 87 minus 75, and that's going to give us 12. Third step, subtract. What do we do next when we're long dividing? If you're thinking, bring down the 5, you are correct. So the last step, once you've subtracted, is to bring down the remaining terms. I'm not going to fit the word remaining, so I'm just going to write the terms. And then we just repeat that process. How many times does 25 divide into 125? In this case, it's actually going to divide evenly 5 times. Distribute that number back. 5 times 25 is 125, and we have a remainder of 0. Let's take this example and let's translate it to a polynomial long division example. This is actually example 3 of the notes. If you've watched part 1 and part 2, you did example 1 and 2. And for this problem, we're going to divide x squared plus 9x plus 20 by x plus 5. Rewrite the problem, and I'm going to give myself some space. So we're going to do x plus 5 on the outside, and x squared plus 9x plus 20. Here, instead of digits, we have terms. And so we're going to apply this same process, but we're going to be thinking of terms instead of digits. Step 1 is to divide the first term. So here, the first term is x squared. The first term is x. So we're going to start with x squared divided by x. X squared divided by x is x. Step 2 is to distribute that quotient back into the divisor. Now, we know the distributive property because we're working with polynomials. Make sure that we multiply this x to the x and the 5. And we really want to align like terms. So x times x is x squared. Line it up with the other x squared. X times 5 is 5x. From here, we move on to the next step, which is subtract. When I'm subtracting, I'm going to go ahead and put 2 minus signs. The x squareds cancel, and that's what the desired outcome. We want that to eliminate. And then we find our remainder. 9x minus 5x is 4x. After subtraction, we bring down the next term. In this case, the next term is 20. And now we repeat that process. Take a second for yourself to consider what the next step or the first step of round 2 is going to look like. If you said it's going to be, I need to switch colors, 4x divided by x, you are correct. Our next division is 4x divided by x, which is 4. So up top in our quotient, we're going to put x plus 4. When we distribute that back, we're going to get 4x plus 20. And you might already be able to predict what's going to happen, but we're going to keep going with the full process. Now we subtract. 4x minus 4x cancels. That's expected. We need that to happen. 20 minus 20 also cancels, which means in this case, the remainder is 0. There's a few different ways to write your answer. Since the process I'm looking for here is division, it's okay to just write that the answer is x plus 4. But keep in mind the overall context of what we're trying to do. We've now just discovered that x squared plus 9x plus 20 divided by x plus 5 is equal to x plus 4, which is also another way to say that x squared plus 9x plus 20 is equal to x plus 5 times x plus 4. This is going to help us later on as we learn new techniques with polynomial functions. Let's take a look at another polynomial long division problem where the remainder is not equal to 0. I'm also going to increase the challenge by increasing the degree of both the dividend and the divisor. So here for this problem, we're going to divide 2x to the 5th plus x to the 4th minus 6x plus 9 by, I forgot the word divide, minus 3x plus 1. So this should say divide this by this. Start with your setup. Which number goes on the outside and which number goes on the inside of your division symbols? I think I'm going to need quite a bit of space for this, so I'm going to push my work over to the left, and I'm going to put x squared minus 3x plus 1 divided by 2x to the 5th plus x to the 4th. Now, if you've noticed, we have some missing terms in this polynomial. There's no x cubed, and there's no x squared before we get to the x. It is recommended that you put a placeholder for every missing term along the way in your polynomial. So here, I'm going to put a placeholder for x cubed and x squared, and I'm going to go through the division process. It's going to take me some time to get from x squared all the way through. So it looks like it's going to be 1, 2, 3, 4 steps of division. Starting with the leading term, we're going to do 2x to the 5th divided by x squared. If you need some scratch work on the side, it looks like that. This division is 2x cubed, and you can check that work by multiplying it back. 2x cubed times x squared is 2x to the 5th, matches. 2x cubed times negative 3x is negative 6x to the 4th, and 2x cubed times 1 is 2x cubed. I need to subtract these terms, and we'll see in this problem that we are subtracting a negative. which is the same as addition. So here, the 2x to the 5 cancels, which is what we expect and need to happen. But x to the 4th minus negative 6x to the 4th is 7x to the 4th. And 0 minus 2x cubed is negative 2x cubed. Bring down your remaining terms. 0 minus 6 plus 9. We're going to repeat that division process, and we're going to do 7x to the 4th divided by x squared, which is going to simplify to 7x squared. Pardon my error here. This should say 7x squared. Distribute that back. You get 7x to the 4th, which is a great way to check that you did it correctly. Then you get minus 21x cubed plus 7x squared. We need to subtract, minus, addition, because 2 negatives. And this gives us 7x to the 4th canceling. Negative 2 plus 21 is 19x cubed. And 0 minus 7 is minus 7x squared. Bring down your next terms and repeat. We're now dividing 19x cubed by x squared. That's going to give us 19x. Distribute the 19x. If you have not been using a calculator, now is a good time to use one. We're going to get 19x cubed. 19 times 3 is going to give us 57x squared. And then 19 times 1 is thankfully just 19. Subtract. Plus, minus, these cancel. Negative 7 plus 57 is 50x squared. Negative 6 minus 19 is negative 25, and we bring down the 9. Okay, I'm definitely out of room on my paper. Hopefully you're not out of room on yours, because this is the last step, and we can tell because the degree is the same. 50x squared divided by x squared is 50. If I distribute that back, I get 50x squared minus 150x plus 50. I'm going to subtract these, which is going to be minus plus minus. And this is going to be my remainder. So I'm going to write this off to the side, but typically I would write it underneath and then circle my answer. So when you have a remainder, and let's put it in a big box right here. Let's talk about how to write it. Remainder. So we write our remainder as the remainder divided by the divisor. So here, 50x squared minus 50x squared cancels. Negative 25x plus 150x is 125x. 9 minus 50 is negative 41. That's our remainder. And we write our remainder as an add-on to our quotient over the original divisor. And this is our final answer up here at the top, from the 2x cubed all the way to the remainder. That's the end of part 3, polynomial long division. We did one fairly straightforward example and one more complex example. In the next video, we're going to talk about synthetic division as a shortcut method for specific types of polynomial division problems.